So this question says thiols are foul-smelling organic sulfur compounds with functional group SH. Butane 1-thiol, shown below, contributes to the strong smell of skunks. How many carbons do I have in this case? 1, 2, 3. Thiols are weak acids. This means they can release H. Write expression for the acid dissociation constant Ka for the butane 1-thiol. Butane 1-thiol, I'll say 1, 2, 3, 4 carbon atoms. Agreed? Now, 1, 2, 3. Here I can. So if I write it down as a molecular formula, what will it be? 1, 2, 3, 4 C4 H10S will then change into C4 H9S minus plus. But this will be reversible reaction. Now, based on this, I can write down the equilibrium constant expression. So Ka will now be written as products, which is C4H9S minus times H positive over C4H10. I'm happy with that bit. Has anyone got any questions so far? Next part says thiols react with carboxylic acid to form thiol esters. So they are giving you a bit of information, and we've been given carboxylic acid. So if I draw a carboxylic acid, it is R-C-O-O-O-O. And if you recall, it is this section of the molecule that will combine with H to form water. Write an equation for the reaction of butane 1-thiol with ethanoic acid. Got this is my butane 1-thiol, so I can say 1, 2, 3, 4, and S dash H plus, which acid do I have here? Ethanoic acid will be C double bond O dash H O dash C. Do we agree with this bit? Now what will happen? Hydrogen from here, OH from here. They will come out as water, and the remaining molecule I can write it down together. So that will be, I'm going to write it down together. So C4H9 dash S dash C double bond O dash CH3. The next part says when beer is exposed to light, 3-methyl butene 1-thiol. So this is important because this is my main chain. Butene 1-thiol is formed, which gives an unpleasant smell and flavor to beer. Draw the skeletal formula. You have to draw the skeletal formula. Now I would not go for skeletal formula straight away. What I'll do is first I'll draw the displayed formula for this. For that I'll need to have how many carbons? 4, because it's butene. On the first one you have SH, and it says butene, so I'll have a double bond at this location, and on the third carbon you have a methyl group over here, CH. Now I can change this into a skeletal formula. So how many carbons do I have in the main chain? 1, 2, 3, 4. Do I have 1, 2, 3, 4 carbons? Okay, that's fine. First carbon, second carbon, and second and third carbon, there is a double bond here at this location. Job done. Now, on the third carbon atom, I do have a CH3, so I did put that. And at this location, I have got S. Did I miss out something there? Yes. So, will it be S there, or will I need to put a dash and then S? I'll have to put a line, and then I'll say here I have S. Done. So 1 carbon, 2 carbon, 3 carbon, 4 carbons. On the second, after the second carbon, okay, third one I do have a bond here. I do have a CH3. That's fine. Now to move on. Okay. Next question here. I did put star on this question because it's an important question. It says propane 1,3 diethanol reacts with carbonyl compounds in a condensation reaction to form a cyclic organic sulfur product. They've given you something important, so it will be a cyclic organic sulfur product. Write an equation for the reaction of propane 1,3-dithiol with propanone. So let's first draw the structure of this molecule. The structure of this molecule will look like propane means it has 3 carbon atoms. On the first one you have HS, on the last one you have H, and this then combines with propanone. What is propanone? I've got CH3 C double bond O CH3. Now the question tells us something important here, and that is, it says it forms a cyclic organic sulfur product. Cyclic means it has to turn into a cyclic compound. Now I can't add anything to this carbon. I can't add anything to this carbon. The only way I can change this molecule when I combine it with this one into a cyclic one will be remove this oxygen from here and introduce 2 single bonds on this carbon. Are people with me on that bit? So what will happen in this case is this hydrogen will get removed, this hydrogen will get removed, and this oxygen will get removed. If I remove them, I can then say carbon, carbon, and carbon. Are we happy so far? This is the same molecule coming from there. I can have a sulfur, I can have a sulfur. So this is the section that I have got here once I have removed these 2 hydrogens. Now I need to add a carbon, another carbon. This is this carbon atom. Then I can have CH3 here, and I can have CH3, and this will be my final product. But in addition to this, there will be something more. That will be H2. So I'll have this as my. There was asking me on the last question, do I have to put a H here? Yes, you do have. Let's move on to the next question. Now, the next question is the last question on this paper, and it's a 6 marker. Now, for this question, I do want you to put your pens down and just listen to me first, and then I'll give you guys time to copy everything. Here it says the structures for 6 naturally occurring organic compounds with pleasant smells B to G are shown below. The common names in brackets relate to their sources and smell. Now, once I've done this, I've read the question, I've highlighted already a lot of things on these molecules. Why did I highlight them? So that I can work out what kind of functional groups are present. I've got alkene, I've got another alkene. And I can see I've got alcohol. Now, when it comes to alcohol, we have 3 types of alcohols: primary, secondary, and tertiary. So we have to identify what type of alcohol is this one. On this carbon atom, there's a carbon, CH3 group. There's carbon on the right side. There's a carbon on the left side. So this will be 3rd degree. It's a tertiary alcohol. And it's a tertiary alcohol, I can recall it cannot be oxidized. It cannot be oxidized. In the next case, again, I've got an alkene, and I also have another group here. What is that group? Let's pass it to Mr. Uzair. What is this group for? In your exam, they give you questions with skeletal formulas. You have to think about it. What would it be?
What do you mean by
What functional group is it? Is it alkene? Is it alcohol? Is it carboxylic acid?
that's a key?
How is it ketone? For a ketone, you need 2 CH3s or 2 alkyl groups on both ends. In this case, on this carbon atom, there's a hydrogen above. So when you have C double bond O dash H, this will be my aldehyde. Will be my aldehyde. Moving forward, when I look at D, again, D also contains a double bond. D contains a double bond, so I can then say again, on this carbon atom, there will be 2 hydrogens. If I can see 2 hydrogens in this case, this will now be my primary alcohol. Agreed? Okay. Next one here, I don't have double bond now. So I can't use bromine water will not give me a positive test with this. But I do have something which is C double bond O here. So I can say this will be my ketone. Letter F is again an alcohol. And if you look at this, this is I can say it is alcohol, but it is not primary alcohol anymore. It is neither tertiary alcohol, because on this carbon there's a hydrogen, so it will be classed as secondary. If I look at the next one, again I do have alkene, and I've got C double bond O here. What's this one again? This will be, how is it aldehyde?
Oh, sorry.
Ketone. So I can add a bit more information here. So it is third degree alcohol plus alkene. Alcohol plus alkene. Aldehyde plus alkene. Okay. Ketone plus alkene. Now quickly copy this information on your sheet, and then I'll discuss the test. It should be open. Now I can say here on this question, the first thing I can do is I can say I'm going to do B, C, D, E, F, and G. I'll add BR2 to all of them. Don't do anything, just listen first, please. I will add BR2 to all of them. When I add BR2 to all of them, which one will give me positive result? B, C, D, and G. Positive result will be by B, C, D, and G. Agreed? When I look at the other two, which is my E and F, they'll give me negative result. Are we happy with that? So this means these ones, all of them, what will they do? Round to agreed. In this case, it will stay. The solution will stay. Are we happy with that bit first? Okay. Then now I've separated them into two categories. I know these two, there are two test tubes with E and F. So if I look at the right side only first, E has ketone group, F has alcohol group. I can then say I'm going to add to both of them. What will I add? I can say I'm going to add Cr2O7, 2 minus, has to be acidified. And if I do that, which one will give me positive result and which one will give me negative result? Then I can say F will oxidize because it's a secondary alcohol. It will change into ketone. Okay, so in case of F, it will be positive and it will go from orange to green, and E will show no reaction. Are we happy with this so far? So we have identified out of 6, we now have access to 2 of them. We have clearly separated. We are now left with 4 of them. Which ones? B, C, D, and G. B, C, D, and G. Then I can say, in this case, if I add, I've got ketone B, so which one is gone? E is gone, and F is gone. I'm left with B, C, D, and G. What I can now do is, in this case, is from here, if I add 2,4-DNPH, what does 2,4-DNPH do? It will identify the presence of carbonyl compound. So I can then say with B and D, it will not give me positive results. So I can say B, D, they'll give me negative results. However, C and G, they will give me positive result. And what will happen in this case? If it is 2,4-DN pH, it will form orange PP. Now, if you look at C and G, one is aldehyde, the other one is ketone. One is aldehyde and the other one is ketone. How do we differentiate between aldehyde and ketones? I'm going to say, now I'm going to add Tollens reagent. And when I add Tollens reagent, what will happen? In case of C, because it's an aldehyde, it will form silver mirror. With C, it will be positive test and will form silver mirror. With D, there will be no reaction. Are we happy so far? So we have now got, out of 6, 4 are identified. We are now left with only 2, B and D. B and D. To B and D, if I add here acidified Cr2O72 minus, one is 3rd degree alcohol. Which one is it? It's B. With B, there will be no reaction. With B, there will be no reaction. But with D, what will happen? It will change from a positive reaction, and this will change from orange to are we happy? One of the very important questions, right? Because it kind of tests you on all of your understanding on this section. Yes, Mr. Roser.
Well, the bromine test at the start, was that the test for unsaturated?
Yes, so for the presence of double bond.
But how come doesn't E have a double bond?
With this is C double bond. It's not a
Oh.
double. It's not a double bond between carbon and carbon. If it was if it was a double bond between carbon and carbon, then it will detect its presence. Okay? Can I please ask you all to quickly copy that, and then we'll move on to the next question. Has anyone got any questions? So what is happening here is they're saying it's a weak acid. A is a weak acid. It is monobasic. This means it can accept one OH, or I can say it can give one H plus. Then it says the student is supplied with 250 centimeter cube of solution prepared from 2.495 grams of A. What does this mean? This means they took 2.495 grams of acid, then they added 250 centimeter cube of water to it, and they got the solution. Then it says the student titrates 25 centimeter cube of sample of this solution with this NaOH. They took 25 centimeter cube of this and they reacted it with, this is now NaOH, which is 0.0840 mole per dN. And then when they titrated it, they did it 4 times. One was the rough titration, and then they repeated this 3 times. And when they repeated it, they took the pictures of the burette, and they've given us a picture of the burette. It now says record the students' readings and the titers in an appropriate format. Then calculate the mean titer that students should use for analyzing results. Now, when it comes to the appropriate format, Uzair, what will it look like? This is what I'm asking you. So when you did this experiment in school, what did you do before you started titration? You must have drawn a table.
Yeah.
And what did you do in that table?
We made separate categories of them.
So what will you say? Yes, that's what this appropriate format means. We'll go starting value and final value. And if I take the difference of the two, that will give me the volume. Now, how many measurements do I have? 1, 2. So once I've done this, I see these two are at difference of this, so these are my concordant values. So when I'm going to work out the mean factor, it will be 22.55 at 22.45 divided by 2, and if you do that, you'll end up with an answer which will be 22.50 centimeter. Now remember, this is the volume of what? This is the volume of NaOH. Are you happy with that? Because we took 25 centimeter cube of the acid solution. And this is coming from the butyrates, and this is our NaOH. Next part, the structure of compound A is shown below. So this is the structure of compound A. Compound A has 4 optical isomers. 4 optical isomers means there are 2 chiral carbons. Says using this information and the student's results, answer the following. Determine the molar mass of A and the formula of the alkyl group R. To work out the molar mass of A, what will I need to do? I'll have to use formula moles equals mass over M. Now I do know the value of mass already. I do know the value of mass already because it was given at the start of the question, which is 2.495 grams. We have to work out the moles of what? A in 250 centimeter cube. So the first thing is what I'll do is, they gave us some information here, monobasic. So if they are monobasic, this means it can accept 1 OH. And the alkali that we are using is NaOH. So I can recall acid to alkali ratio will be 1:2. Are we happy with that bit first? So whatever the moles of alkali we have used, there will be same amount of moles present in 25 centimeter cube of acid solution. So I can say step 1 will be moles of NaOH used. I can use CV over 1000. This gives me concentration, in my case, is given to me as 0.0840. The volume I worked out in the previous part, which is 22.50 divided by 1000, gives me answer as 1.89 times 10 to the power of minus 3 moles. Okay. Number 2, then I can say moles of acid in 25 centimeter cube will also be same, which is 1.89 times 10 to the power of minus 3. How do I know this? Because the mole ratio for acid and alkali is 1 to 2. Number 3, I can then say moles of acid in 250 centimeter cube, which will be 1.89 times 10 to the power of minus 3 times by 10, and this gives me 1.89 times 10 to the power of minus 2. So these are in 25, these are in 250. Now I know the moles of acid. So we are assuming our acid was pure acid. Our acid was pure acid, and based on that, number 4, I can then say mole equals mass over mR. Moles are 1.89 times 10 to the power of minus 2. Mass was 2.495 over mR. From here, my mR turns out to be 132. Okay. Now once I know my mR, I've been given part of the molecule. So I'll go back. And they've given us 2 pieces of, one is R is alkyl group. So basically my R is CnH2n plus 1. Okay, number 1. Number 2, I can say to work out the mR of this, how will I work out the mR of this? How many carbons are there? Carbon. There's a hydrogen here as well. So how many carbons do I have? C2 1, 2, 3 hydrogens. How many oxygens? 1, 2, 3 oxygens. Can you work out the MR of this section? Plus R. So how much is the MR for this? So if you do 12 by 12, 75 plus R, and this is my MR of this molecule. Are we happy with this? So I now know the value of MR. On the fifth step, what I can do is my step 5, I'll have to bring that value from the top, and I can say step 5 will now be 75 plus R must be equal to 132. We do minus 75 minus 75. This is gone. We're left with R being equal to 57. Now you can do whatever method you want. You can try it. This is not CH3. This is not C2H5. This is not C3H7. This is equivalent to C4H9. So R is C4H9. Now for the fifth step, so we are done with the first part. It now says draw the structure of compound A and label any carbon atoms with an asterisk. So I'll say now I've been given that. Let's start from here. I can say there's a hydrogen, there is HO dash C double bond O dash OH, and below this is my R. Now what is R? R is C4H9. Can't have I can't write C4H9 because I have to show them that my molecule contains 2 hydrocarbons. And for that, what I'll do is I can put C here. But if I put hydrogen here, CH3 here, and C2H5 here, gives me something special now. Why? Because I can see around this carbon atom there are 4 different atoms or groups attached. So it's carbon number 1. This carbon also is a chiral carbon. Why? Because it has 4 atoms or groups attached to it. And that will be step number 6. So what I said is, before I move on with this question, I have to identify that there are 2 functional groups on this molecule, a carboxylic acid and alcohol. So if more than one of these molecules are present, they can form ester linkages. Here it says you are carrying out 2 reactions. One of the reactions is you are reacting this molecule with magnesium. Magnesium is a metal. We know when metal will react with acid, it will produce salt and hydrogen. Now in this case, it says write down the equation. So if I write down this molecule again, I can say it will be C dash C double bond O dash OH. This location you have nothing here because you can have, otherwise you'll have 5 bonds here, so you can't have this here. You will have a hydrogen here, HO here, and at this location we have got R. If I react it with Mg, it will change into, only change into H2 will be given out. Now it can release only 1 hydrogen. So if it releases 1 hydrogen, this means if I hide this hydrogen from here or take it away, it will form 1 minus ion. But magnesium will produce 2 plus ions. So what will happen in this case? I'll have to write it down as HO dash C H dash R dash C double bond O dash O negative times by 2 and Mg2 plus. Now in this case it says type of reaction. You can clearly see here hydrogen here from acid was 1 plus, it has gone to 0. Magnesium was 0, it has gone to 2 plus. So it's a redox reaction. Okay, next part. It says compound A is heated with few drops of concentrated sulfuric acid. Few drops of concentrated sulfuric acid as a catalyst. A cyclic dimer. What does dimer means here? Any idea, Mr. Uzair? Say cyclic dimer. Dimer means it is made up of 2 molecules. So 2 molecules merged together. Now we are using concentrated sulfuric acid. What is this for? This is for esterification. You have it. Now what will happen in this case again? I will draw them together and I will see what it can produce. So if I copy the top sections once again, I have one molecule which is HO-C-H-R-C double bond O dash. I'll have another one of this which is HO-C-H-R-C double bond O dash. Now it does say it is a cyclic diamond. Cyclic means it has to become a molecule with which will be closed in shape. So I can say this will go from here, this will go from, this will go from here, this will go away from. So how many molecules of water will I have? A molecule from here, a molecule from here. So I'll have, so I can straight away say it will produce 2H2. I need to find a way of writing it together in the form of a cyclic structure. So I can see if I start from this molecule and if I copy this whole thing first, I can say it will be O-C-H-R-C double bond O. And now below this molecule, I'll copy this molecule, but I will have to pick it up from here and I'll flip it and then I'm going to put it over. So if I flip this molecule and write it down here, or I can say I'll write it down in reverse order, like C double bond O. I can link these two together. Dash C dash H dash R dash O, and this will link together. These are the bonds which have linked together. Now the type of reaction in this case, it will be called esterification. Chromium 3 picolinate shown below is a natural complex that can be prepared from the weak acid picolinic acid. Chromium 3, what does this mean? Chromium 3, this means CH has a charge of 3 plus. CR has a charge. This means CR has a charge of 3 plus. Is used in tablet as a nutritional supplement for chromium. Draw the structure of the ligand in chromium 3 picolinate. Before that, I have to pick up this keyword here. It's a neutral complex. It's a neutral complex. This means how many ligands do I have around it? Look, there is one ligand here, there's one ligand here, and there is another ligand here. Each ligand is forming two dated covalent bonds. So it's a bidentate ligand. And each one is bidentate, plus it will have a charge of 1 minus because it's a neutral complex. Neutral complex means this 3 plus has to be removed by these 3 ligands. Are we happy with that? Now, next part says draw the structure of the ligand in chromium 3 picolinate. So the ligand is, I've already shown it to you. These are my ligands. I'll just copy this structure, but I'll have to show the charge of 1 minus on it. So I can say 1, 2, 3, 4. Yep, this, that. And next to this, I have double bond here. I'll be happy with this part. There's one, okay. One double bond here. There's one double bond here. And there's one double bond. So you've got to be careful with the bonds. They've shown that this has bonded to the chromium ion. What does that mean? This means This will have a lone pair. This will be negatively charged. And this nitrogen has also bonded to the chromium using a dated covalent bond. Will I show a bond on this too? I can, but I don't have to. But this is the most important thing that has to be negatively charged. Done. Now next part is only 2 marker, but there is one concept that we have to keep in mind. So the main thing that you have to remember here is that the moles of chromium will be equal to the moles of, in this case, chromium 3 picolinate. I'm saying here that the moles of chromium will be equal to the moles of chromium picolinate. Are we happy with that? Why? Because in each complex there's 1 chromium, and 1 chromium means the moles of chromium will be equal to the moles of complex ions. Agreed? Now, once I know this, they've given me some information here, which is 200 micrograms of chromium. It can be converted. I can convert this into moles of chromium, and this will be, mass will be 200 times 10 to the power of minus 6 divided by the MR. So if you go to your periodic table, you will notice the MR for chromium is it 52? Yes, it is 52. So AR for chromium is 52. If you divide that, you will end up with an answer. What is that answer, Mohan? Have you got an answer? 0.015. Check once again.
Oh yeah.
It should be 3.85 minus 6 moles. So the moles of chromium will also be not chromium. So I can say this is also equals moles of chromium 3 picolinate. Now the question says calculate the mass in grams of chromium 3 picolinate in a typical tablet. In a tablet, there are this many moles of chromium 3 picolinate. All I need to do to find out the mass, I'll use the formula. Moles equals mass over MR. Now it's another challenge to work out the MR of the molecule, which is above. So when it comes to this, I'm going to say, to find the MR of this molecule, I will use my approach, which will be 3 times ligand plus CR. Are we happy with that? Because there are 3 of the ligands. So I can say 3 times the MR of each ligand plus the chromium molecule. That will give me the MR of this molecule. What's the MR? How many carbons do I have in ligand? 1, 2, 3, 4, 5, 6. How many hydrogens do I have in ligand? 1, 2, 3. Okay. 1, 2, 3, 4. 5 hydrogens. No, they're not 5. There is no hydrogen here, so just 4. How many oxygens do I have? 1, 2, and N. If you work that bit out, what do you get? Anyone tell me what did you get for that? Got that as 122 plus 52, and this gives me answer as 418. That's the MR of my. So I can then do moles. I already know, which is 3.85 times 10 to the power of minus 6. Mass is not known, but the MR is now I know 418. If you cross multiply and work out the mass from here, you'll end up with mass being equal to 1.61 times 10 to the power of minus 3 grams. Now question 3 is about the rate equation, and we know rate equation can only be worked out using experimental data. So here what is happening is, it says this question is about the reactions of hydrogen peroxide, H2O2, iodide ions and acid H plus react as shown in the equation. So this is my equation. How many reactants are there? 3. And we can then change the concentration of each reactant without changing concentrations and temperature of the other reactants and H2O2. What will happen then? We can work out the rate of each reaction. So it says student carried out several experiments at the same temperature using the initial rates method to determine the rate constant K for this reaction. So I can then say, in this case, this is 1, 1. Did I change the concentration of H2O2? No. But if you look at it, this is also 1 and 1. I've changed the concentration 1 and in this case, the only thing that has changed is the concentration of I minus. So if you double the concentration, my rate doubles. So this means with respect to I, it is first order. It is first order. Then I can say in case number 2, 2 and 2, this is 2 and 2, 2 and 2, 2 and 2. What did I do in this case? I have only changed the concentration of acid. I've doubled the concentration of acid. Nothing else got changed. The rate did not change. This means with respect to H plus, it is 0 order. Then I can say I'm going to compare these ones now. So 3 and 3, 3 and 3, 3 and 3. So when I look at these rows of data, the only thing that has changed is the concentration of H2O2. It has been doubled, and I notice again the rate has been doubled. So with respect to H2O2, it is also first order. I can then say my expression for the rate will be K times I minus times H2O2. I can write down H positive, and I'll put 0 on top, here I'll put 1, here I'll put. Are we happy with that? And then we know from maths, anything to the power of 0 is always 1. So I can get rid of this. My rate expression will now be equal to K times I minus and H2O2. Now it says what are the units, and it does say here calculate the rate constant K including units. So all you need to do is you pick up one of the rows from the top and you put the values in, and if you plug in the values, what will I get? Let's use the first one. I'm going to use experiment 1 data in this equation. The rate is 2 equals K. Concentration of I minus is 0.01. The concentration of H2O2 is also 0.01. If you solve from here, you'll end up with the value of K, which will be equal to, has anyone got an answer? 2 and 4 zeros. Check again. Because look, I made a small mistake. Can anyone identify the mistake that I made? Look, for the rate, it says the rate is 10 to the power of 6 mole dN. So I'll have to do, it should be 2 times 10 to the power of minus 6. Now, so be careful with that bit. I'm highlighting this section here as well. Do take it into consideration. I can then say the value of K will now be 0.02. The unit in this case will be, I can work out the unit for rate is always mole dm to the power of minus 3 s to the power of minus 1, and I'm dividing mole dm to the power of minus 3 mole dm to the power of minus 3. So I've got 2 of these concentrations. So I can say one of this will go away with this one, they cancel out. I'm now left with unit will be mole to the power of minus 1 dm to the power of 3 s to the power of minus 1. Now the next question says the rate constant K for this reaction is determined at different temperatures T. Explain how student could determine the activation energy for the reaction graphically using the values of K and T. Just remember this is equation which is given in the equation sheet, so this is taken from equation sheet. Now what will I do in this case? I'll say plot graph of ln k against 1 over t, number one. And number two, I'll then say gradient of that graph will be equal to minus EA over R. And to find out EA, you will have to do gradient times minus R. It will give you the value of, because the gradient in this case will be negative. So when you multiply negative with negative, R will become positive. But remember, this value of EA will be in joules. The question might ask you to convert it into kilojoules. So in that case, you'll have to divide the value by 1,000. The next part is good again. Why is it good? Because it asks, this time they've given us these three equations and they want us to apply our understanding of something that can behave as catalyst. So yes, a solutions of hydrogen peroxide decompose slowly into water and oxygen. They decompose slowly. The reaction is catalyzed by manganese dioxide, MnO2 solid. Standard electrode potentials are shown below. Using the electrode potentials, explain how MnO2 is able to act as catalyst for the decomposition of hydrogen peroxide. Your answer should include relevant equations. What is a catalyst? It doesn't get used up. Number one, or we can say gets regenerated. Are you happy with these two concepts? So if we can show the regeneration of the catalyst, then things will become accessible for us. So I've been given three equations, 1, 2, and 3. So first time what I'll do is I'll consider this and this equation. I'll consider this and this equation. So if I look at equation 2 and 3, what happens in this case? This one has a bigger electrode potential. This equation has a smaller electrode potential. So I can say this will go in the forward direction, this will go in the backward. Agreed? So if this goes in the forward direction, this goes in the backward reaction, I can rewrite these equations as H2O2 plus 2H positive plus 2E minus. This gives me 2H2O. And I can then say the top equation can be written in the reverse order. So it will be 2H2O plus Mn2 plus, I'm doing something wrong.
So I was thinking you have to use the
First two equations.
if you're showing how axis of balance, then it have to be on both sides.
Yes, that's what I'm thinking, right? Because H2O2 has to change into this. Okay, 1 second. Let me check. Listen first. So if I look at 2 and 3, I wrote the third equation first. It has a bigger electrode potential in the forward direction. Second equation will go in the backward direction, giving me 2H2O plus Mn2 plus, and this will then produce MnO2 plus 4H positive plus 2E minus. If I write down the overall equation, my electrons are balanced now. So I can see this and this will cancel out, and it gives me from this and this, they both will also cancel out. So I can say it will be H2O2 plus Mn2 positive plus 2H positive will give me MnO2 plus 4H positive. Are we happy with that? Now what I can do is I can pick up equation number 1 and 2. So I'm going to pick up now equation 1 and 2. So I can see in 1 and 2, this one has a bigger electrode potential. This will go in the forward direction. So it will be MnO2 solid plus 4H positive plus 2E minus. It will change into Mn2 plus 2H2O. And then I can rewrite the top equation as H2O2, and it will change into O2 plus 2H positive plus 2E minus. The two equations are both contain the same amount of electrons. I can say the electrons will cancel out. What will I now have? I can say this will then become, overall equation will be MnO2 plus H2O2 plus 4H positive, and this will give me Mn2 plus 2H2O plus O2 plus 2H positive. You can then simplify this a little bit more by saying this will be 2H positive and this will be con. Okay. Now, this will be my step 1 when the reaction will take place. Why? Because I am using this as solid. Okay. This will be my step 2 in this reaction. Why? Because in this case, MnO2 solid has now been what? That makes sense. Okay. Can I please ask you to copy it in? Next part says peroxy carboxylic acids are organic compounds with this functional group triple OH functional group. These acids is used as disinfectants. So just the structure of this functional group must be clearly displayed. You have to pick up this. So I can say if I start with this, CH3 is there. Now I need to add OOH. Now I know oxygen can have 2 bonds around it. I can add another oxygen and then I can add. That makes sense. Our next part is again an equilibrium reaction. They've given us some data. They've given us the value of Kc, and they're saying for this given reaction, the concentration of H2O2 is given to you. The concentration of CH3COOH is also given to you. So this is my R1, reactant 1. This is my reactant 2. And the question says, work out the amount in moles for the, this is my product in the equilibrium mixture. Now what will I write down as my Kc equation for it? My Kc equation will be equal to CH3 C triple bond H over H2O2 and CH3COOH. Why did I not include water in this case? Water is one of my products. Why will it not be related to this expression? But can the concentration of water ever change? No. Can the water concentration ever change in this case? Yeah, water has no concentration. So we can then say we just have to plug in the values now. So this will be 0.37 equals CH3COOH over 0.50 times by 0.5. And from here, we'll end up with a concentration of C triple bond O. It's C triple OH. It will then become equal to 0.0925 mole per dm cube. Now the question is asking you to work out the moles, so you can't leave your answer like this. You have to use moles equals C times V over 1000. Okay. So to work out that, I'll then do 0.0925 times by volume, which was how much? 250 over 1000. And this will give you a value of moles, which will be 0.023. So far on this question, what did we do? We've been given direct route and we've been given 2 equations, but the final product gives us the same product. So we said this is my direct route, this is my indirect route. From one of these equations, I've been given the value of delta HR. For this reaction, I'm using Hess's law, not Hess's law. We are using calorimetry. And for that, what I did, they followed this method and they've got these values. So if I use these values, I'll end up with the mass of Na2O. From this, I'll work out the mass of solution. From here, I can work out the change in temperature. I'll pick up this value from the data booklet, and there are 3 things that I need to do. to calculate enthalpy change, first thing is I'll work out delta Q equals mc times delta T. This value is from the data booklet. This is from the change in temperature. I've just made one note here. Change in temperature in Kelvin is same as change in temperature in degrees Celsius. So the values are same, so make sure you keep that in mind. Once I plug the values in, I've got the value of delta Q as 3767, and I worked out the moles of solid Q's. Mass was given to us at the start, 1.24. From here, I can divide that by 62. That's the MR, gave me the moles. I divide delta Q by moles, it gives me the value in joules per mole. I now need to convert it into kilojoules. For that, I divided by 1000. Then I looked at this data and I said here the temperature has gone up, so it means it was an exothermic reaction. So if it is an exothermic reaction, that means I'll have to add negative with all my values. That will be my answer.
Sir,
Yes.
Kelvin T to degree, is that always going to be the case?
When you are doing delta T, change in temperature will only be. Next question. Here it now works. It talks about the uncertainty in each temperature reading is 0.1. Now remember what we did was we have recorded for each temperature. How many readings of temperature did you take? 2 readings were there for the temperature. In each mass, how many readings were there for the mass? 2 readings again. So the total uncertainty will be sum of 2 uncertainties. So to work out the temperature, I'll have to do 2 times 0.1 over, all I do, divided by, what was the change in temperature? So I'll divide it by 35. I'll multiply this by 100. For the mass, I will do 2 times 0.005 over, what was the total mass? 1.24, times it by 100, and this will give me the percentage error. Now, if you work it out for the top one, you will end up with a value of 0.57%, and for the left one, you'll end up with 0.80%. So which one has bigger error? Mass has bigger. Done. They made 2 readings for each value, right? So they made 2 values of the mass, they made 2 values of the temperature. So when you have 2 values that you use for work out your value, you'll have to add your uncertainty twice. Last question, part C. So it's just a modification to this experiment using the same apparatus which could reduce the percentage errors in the measurements. You have to explain this answer as well. So if I have to reduce this error, what will I do? I can't do anything to my numerator. The only thing that I can do is I will have to change the denominator. This is the mass of Na2O, so I can say use bigger mass of Na2O. Or I can say use masses that will result in bigger value of delta T. Okay, I can say use larger mass of Na2O. Now if you use larger mass of Na2O, what will happen? Then the percentage error in mass will go down, number 1. And also percentage error in temperature will also go down because the delta T will be bigger now. Okay, because delta T will be bigger. Here mass will have bigger value and your uncertainties will remain the same. Now next question here, what is happening? It says sodium oxide Na2O can be prepared by the redox reaction of NaNO2 with sodium metal. So they're telling you react NaNO2 with sodium metal and this will be your product. This is my R1, this is my R2. It says what is the systematic name for NaNO2? This is from your GCSE. Now this is something that is made up of 3 elements and one of them is oxygen. So you'll say it will be sodium nitrite. Sodium nitrite. So because this is 3 elements and then one of them is oxygen. Says using oxidation numbers with signs show the element that is oxidized and element that is reduced in this reaction. So for this I have to write down the equation. So what is happening is it says you have Na2O is produced from NaNO2 plus Na, and it also says nitrogen gas is also formed. This is my product 2. So I can say element oxidized is sodium because it went from 0 to plus 1. Element reduced will be nitrogen. Why will it be nitrogen? Because nitrogen went to 0. What's the oxidation state of nitrogen in this? It will be plus 3. How? Plus 1 is for sodium, plus X, plus minus 4 must all add up to 0. If you work out here, X will be plus 3. So it went from plus 3 to 0. Now it says construct the equation for this reaction. I've already written the equation, but we need to write down the balanced equation. So for that, I'll copy the equation again. NaNO2 plus Na will give me Na2O plus N2. We need to balance this equation. How many nitrogens do I have here? 2. This means I'll have to put 2 here. Once I put 2 here, how many sodiums do I have here? 2. Now, let's not worry about sodium here. How many oxygens do I have on the left side now? 4. So I'll have to put 4 here. So I now have 8 sodiums. Out of 8, 2 are already here. I'll have to put 6. So it will be 6 and 8. Okay. Any questions so far? One last question on this. Within the permafrost in Arctic region of the Earth, large amount of methane are trapped within ice as methane hydrate, CH4XH2O. Methane takes up about 13.4% of the mass. Methane makes up about 13.4. Methane makes up about 13.4 of the mass of methane hydrate. So 13.4% of. So I can then say this means something important, right? So we can change it into expression. I can say 13.4 over 100 times by X, which is the MR of this hydrate, will be equal to methane mass. I'll be happy with that. Now, since scientists are concerned that global warming will melt the permafrost, releasing large quantities of methane into the atmosphere. The H-O-H bond angle in ice is about 109, but about 105 in gaseous H2O. Now you have to remember they've used word gaseous H2O. When it is gaseous H2O, there are no H bonds. Okay. When it is ice, there are H bonds. If I draw a water molecule here, between them two here, what will happen? In this case, there will be H bond here, and this H bond will pull it out. As a result of this, the bond angle will be bigger. But when it is broken, then when there are no more of these hydrogen bonds, then these molecules will be further away. So I can then say in this case, bond pair. Repulsion is less than lone pair repulsion. I'll be happy with that bit. So you get 1 mark for identifying this, and this 2 marks, and then 3rd mark for this. So just why scientists concerned. Why are scientists concerned about the release of methane into the atmosphere, because methane is, what is it? It's a greenhouse. It traps. What does it do? It traps infrared radiation. Next question talks about determine the formula of methane hydrate CH4XH2O. So we have to determine the formula of methane hydrate. They gave us some information at the start that 13.4% of the total will be, what will it be? CH4, right? So I can do that, and if I work out the, can I work out the value of X then? So from the start value, I can say 13.4 over 100 times X will be equal to how much? It will be equal to methane. That's what I said. Now, then I can say 13.4 over 100 times X will be equal to methane will be how much? 12 add 4, 16. Now from here, you can work out the value of X. If you work it out, you will end up with the value of X being equal to, the value of X will turn out to be how much is it? So value of X. Has anyone got an answer? 100 times 16 divided by 13.4. This gives me 119.4. 119.4. So on this question, what I did is I picked up this information from here and I wrote it 13.4 over 100 times the total mass will be equal to methane. From here, I was able to work out the value of the total mass, which is the mass of CH4XH2. Now from this mass, if I take away the mass of methane, I will then be left with the mass of water. If you divide 119.4, take away mass of methane, divide by 18, to give you this value. And then let's quickly move on to this section of the last question, second last question. It says, calculate the volume of methane in dm³ that would be released from the melting of each 1 kilogram of methane hydrate at a pressure of this. So basically in this case, you'll use PV equals nRT. So the pressure in this case will now be 101 times 5,000. We need to work out the value of V. I'll say this will be V equals. So to work out the, it says methane released, volume of methane. Volume of methane will be, again, 13.4% of 1,000 is methane. Does that make sense? So what is that mass equivalent to? 134. 134. If I change it to grams, then I can say it will be 134 grams. I've converted this into grams. So 134 grams will be that. Now to work out the moles, I'll do 134 divided by 16 times 8.31 times by, I can't use temperature in degrees Celsius. It has to be in Kelvin now. So it will be 273. From here, you will end up with a volume. This will be in meter cube. This will be in meter cube. How do I convert this into dm³ now? Divided by 1,000. Times, divide, I don't know, right? So let's have a look. So if I go from 1 meters and 1 dm. So if I go from meters to decimeter cube, what do? I multiply it by 10. No, I'll multiply by 110 here. Here I'll divide it by 10. This time, if I make it cube here and cube here, then I'll have to put cube here as well. So I'll multiply it by 1,000. So from here, I'll end up with a value of volume being equal to, has anyone got a value? The answer tells us that it should be 188 dm cube. Is that what you got from here?
Yeah.
But that would be, so I want first the answer in meter cube. That should be 0.1.
188.
That's fine. 180. So if you divide, so make sure you copy this section as well, please. And then we can do the last bit. We are done with this example. Make a note of this as well, okay? Because this may be in your exam again. So there were two tricks on this question. What were they? You have to use this to work out the mass of methane from 1,000 grams. And then you'll use that mass to work out the moles for this equation. Plus, you need to do two conversions, one for the temperature, one for the pressure. And if you work out, your volume will be in meter cube. Then you need to do a conversion towards the end. And for this conversion, we use this this unit conversion. Now, let's have a look at the last question. It says just why some industries are interested in the presence of methane hydrate in region of Earth. What's the job of the industries? They make products by burning fuel. So they can use this fuel to produce electricity. Use CH4 to produce electricity. You can say they can use it as fuel.